Welcome to this video tutorial. My name is Mark Scythian. The date today is June 4th, 2023. So in this video tutorial, we will be covering Ohm's law and DC electrical power. Ohm's law can be expressed as E voltage is equal to I current times R resistance, pertinent to DC electrical circuits. Whereas DC electrical power can be expressed as P, DC electrical power in watts, is equal to I current times E voltage. So practically, Ohm's law could be expressed as DC voltage is equal to amps times ohms, whereas DC electrical power in watts is volts times amps. Also, Ohm's law can be expressed algebraically with the following formulas below, as can DC electrical power with the three formulas posted on the right side. So on your Prep-Ware, you may run into a question that asked to compute the resistance across, let's say, 3 light bulbs powered by a 24-volt DC electrical generator with 75% generator efficiency, in which each light bulb draws 90 watts of power. So you can use the formulas listed above to answer the question. So based on the question's information, we need to access Ohm's law formulation for resistance on the left and the DC electrical power formulation to compute current in a DC electrical circuit, the power divided into the voltage, and with respect to Ohm's law, the voltage divided into the current. So if we read the question carefully, we have a 24-volt DC voltage source, and each light bulb draws 90 watts of DC electrical power. So we can simply divide the 90 watts into 24 volts to compute 3.75 amps per light bulb as the current draw, and then simply take the source voltage and divide it into the current draw per light bulb to compute 6.4 ohms. As for the 75% generator efficiency, this piece of information is not relevant to the question asked, so that is actually omitted. However, there may be a follow-up set of questions or a question which asks to compute the mechanical power input required to drive the DC electrical generator or its horsepower input. The Prep-Ware will indicate the number of watts per horsepower and may then ask a question which may appear on the FAA written general exam: what mechanical horsepower rating is required to drive the generator? So we know 1 horsepower is a mechanical power rating and is equal to 746 watts of mechanical power, whereas we are using the DC electrical generator to convert mechanical power into electrical power. Both are measured in watts. So the efficiency rating of 75% or 0.75, its reciprocal times the power draw by the 3 light bulbs will equal the mechanical power input. In this case, it's 360 watts of mechanical input is required to drive the electrical generator. So if we simply divide the 360 watts into 746 watts per horsepower, we compute approximately 1/2 or 0.5 horsepower, mechanical horsepower, is needed to drive the electrical generator based on the current draw or load of the given circuit. So you can solve any of these power questions in the Prep-Ware by using these 3 formulas for Ohm's law and these 3 formulas for DC electrical power.